everyone, Mr. Lee here. In this video, I'm going to go over linearization and how to do it. Linearization is one of the more important skill sets that we can use in physics, and it really comes in handy after we collect lab data and we are given a data set that is not in a linear fashion. Now, what that means is that the data doesn't give us a straight line, but gives us something that we see here below. So we have this curved line. So anytime you're given something like that, we can actually adjust the data, not make up data, but adjust the data so that what we end up with is a straight line. And I'll show you how to do that. So this data set that you see before you is something that I made up from a scenario that we could have done in class. So here I have a ball, and this ball is on a ramp. Okay, we are going to release the ball on the ramp until it rolls down the ramp. And we are going to collect the data of how far this ball goes along the ramp from a certain amount of time that has passed. So, long way of putting it, what I'm doing is I'm collecting the position at certain time intervals. So a couple of things. Our initial position will be 0. Our initial velocity will also be 0 because we're releasing it from rest. Now, over here, what you see is the kinematics equation that I'm going to model my data set after. So I made my initial position 0 and my initial velocity 0. So I did that in red to show you that the zeros will just being 0, and we could just cancel that out, leaving us with the equation of the final position, or the displacement in this case, is equal to 1/2 at squared. Okay, so this data set is modeled after this equation right here, and I wrote that in this this little cell. So with this equation, I came up with this data. Okay, at 0 seconds, the position was 0. At 1 second, the position was 0.5. 2 seconds, 2, so on and so forth. And when I plotted that data, I got this beautiful curve. Okay. Now, in order to find the slope of this curve, you have to go through a lot of different processes. But with the help of linearization, we actually don't need to do that. Now, before I go into how to linearize, I want to show you why this even happened. Okay, so if I were to first start off with this equation over here, xf is equal to 1/2 at squared. I'm going to move my data set or my graph over to the right. So if I take a look at this equation, I want to compare this equation to a equation called the point slope formula, which is y is equal to mx plus b. Okay, so this is the formula that's going to transform our data from this curved data into a straight line data. Okay, so I'm going to line up my equation xf is equal to 1/2 at squared with y equals mx plus b, and I'm going to line it up based off of our graph. Okay, so our y-axis is the position. So according to this equation, that'll be xf is equal to our x-axis is time, so I want to put time right here. Okay, but you'll notice that our time in the equation is time squared. Our y-intercept, I made it 0, so that'll be 0. I'm going to put that off to the side. And then we have all of this in between, this 1/2 a right there. Okay, so I'm going to write that here, 1/2 a. So according to this point slope formula, this is what we should end up with. We should end up with our y-axis being x final. Okay, our x-axis should be this t squared, and therefore our slope should be this 1/2 a. Okay, that should be our slope if this data was a straight line. Okay, but we can see here that this is not a straight line, and the reason for that is because our x-axis, this t right here, our data is not in the same format as this equation right here. Okay, and that's because our time is just time and not time squared. So here's something cool that we can do. If we take a look here, we see that according to this point slope formula, and remember this formula gives us lines that are in a straight line, a linear line. According to this formula, our data should have time as being time squared. Okay, so what I'm going to do is I'm going to get this data and I'm going to transform it so that we get time squared, and you're going to see exactly what happens to our graph. All right, I'm going to bring up my data from up here. Okay, so what I'm going to do now is I'm going to create a time squared graph. So I'm going to copy my data set. Oops. I'm going to copy this data set and I'm going to just move it over here so that we can see. All right. And what I'm going to do is, instead of time being 0, 1, 2, 3, 4, I'm going to square all of that data. Okay. So let's move this over here. I'm going to move this to the right a bit. There we go. Okay. So this will be my time squared. Okay. So this will be time squared, which gives us the units of second squared. Okay, so I did a lot of clicking around here and there, but all I'm doing is I'm creating a column so that I can square these values. So 0 squared will be 0, 1 squared will be 1, 2 squared will be 4, 3 squared will be 9, 4 squared will be 16, and 5 squared will be 25. Now, when you have your own data, like this is data I made up, I use the easier numbers. When you do this, actually use a calculator to square all of your data points. Okay, and I'm going to get rid of this chart. So I'm going to show you what our new graph will look like. So I'm going to highlight the time squared and the position. Okay, so I'm going to do insert chart. So I'm going to do that. I get something that looks like this. It's a linear line. Just to prove it, I'm going to create a scatter chart. Okay, so here we have a scatter chart, and I have a, let's give this a line of best fit, a trend line. So I have a trend line. I'm going to do use equation. Okay, and I can see that this is my equation. So I have y is equal to 0.5x plus 0. My data is all in a straight line now, and remember that was the original point, to make our data a straight line. And we want data in a straight line because straight lines are easier to do math with, and it's easier to see like the trends, like what's actually going on. Okay, so we have now successfully linearized our data. Okay, and I just want to show you something cool. Our equation is y equals 0.5x plus 0. So let's go back to our whiteboard. We said our equation was, for our new graph, was, y is equal to 0.5x plus 0. Okay, so if I want to compare this equation with our model equation, our actual physics equation here, so I'm going to write xf is equal to 1/2 at squared. See how cool this is? Our y-axis was our position. Okay, so that lines up. Let me use red. That lines up pretty well. Okay, our x-axis, according to our new graph, remember we linearized it, so it was t squared. Okay, t squared. Therefore, our slope is represented as this: 1/2 times deceleration. And according to the point slope formula, that would be 0.5. Okay, which is the 1/2 times deceleration, and in our data set I made the acceleration 1, so it'll be 0.5 times 1. Okay, so this becomes our slope. Is that cool? All right, so that's how you linearize your data. It's very easy to do in Google Sheets because you can just adjust it on the fly. Now, I'm going to give you a couple more examples of how to linearize your data based off of physics equations. All right, in this next part of the video, I'm going to show you the different shapes of a graph that you might come across and what we can do to our data in order to linearize it. Now, in the first part of the video, what I did was I chose a very specific example, but I'm going to just show you what the general way of doing things so that you can apply this to any set of data or any equation that you come across. Okay, so I'm going to create my graph. This is going to be for all my graphs, it's going to be y versus x. And if we have a flat line like this, okay, so right here, there is no real relationship here because as x increases, the y stays the same. And so in terms of y equals mx plus b, okay, what this means is that our equation is for this kind of graph, just y is equal to b. Because remember, our m is our slope, and if our m is 0, because there is no slope, this becomes our equation. So do we need to linearize here? And the answer is no. No linearization required. Because remember, the whole point of linearizing is to make our data into a more line shape, and because it's already in a line, we don't need to linearize. All right. Now the next one is something that we're familiar with, is if we're given a data set that looks something like this. Okay, so here once again we're comparing it to y equals mx plus b. Okay, this is in the y equals mx plus b format. Okay, that's what it should look like. This is the whole purpose of linearization, is to get this shape or a line shape. And so because it's already in a linearized format, we don't have to linearize at all. All right, the next one that you might come across is this one. So we have a exponential one like this. Okay, and I just showed you that in the first part of the video, right? And here the relationship is y is proportional to the x squared. Okay, and so in order to take a graph that looks like this, okay, a proportional graph like this, to something that's more linear, remember this is a relationship. Okay, the relationship is y versus x squared. What you want to do is you want to collect, or you want to get your x data set, and you want to square it. Okay, so if you square all of your x's, your new graph will look like this. Okay, x squared, and that'll give us a straight line like that. Okay, and your formula will look something like this. So instead of y equals mx plus b, the formula, instead of having just x, we're going to replace the x with x squared, because that is our x and our x-axis, plus b. All right. The next one that you'll see is a graph that looks a lot like the previous one, except it goes downwards, like so. Okay. Now, the relationship here is that as x increases, y it decreases proportionally, like so. And so the relationship that we see here is that y has a inverse relationship, and so the relationship is 1 over x. Okay, so that's what we call a inverse relationship. Now, if we were to graph our data where the x-axis isn't modified at all, we will get a line like this. But if this is a relationship and we want to transform this into a y equals mx plus b format, we just replace, so if it's y equals mx plus b, we have to replace our x with this relationship right here, okay, which is 1 over x. And so we will plot y is equal to m times 1 over x plus b. Okay, so we will get all of our x's, and we will put the values over 1 and replot it. Okay, so if you were to do that, your new data set will give you a linear line. And once again, our x-axis is the relationship, so it'll be 1 over x. All right. Now the last one that I'm going to show you is this graph, like so. So we have y, x, okay, and it looks like that. Okay, so as x increases, y increases, but after a while it kind of like flattens out, like so. Now this is a very special relationship because up until now we always change the x variable in order to linearize it. But for a shape like this, okay, what we're seeing is a y squared versus x relationship. Okay, y squared versus x. And so in your data chart, if you get all of your y values and you square it, and you were to plot it versus the x, okay, so y squared versus x, we would be able to linearize our data like that. All right, and in terms of the point slope formula, which is y equals mx plus b, okay, our new formula, remember all you got to do is replace the within the formula what you see here in your graph. And so instead of y equals mx plus b, your formula will become y squared is equal to mx plus b. So that becomes your formula. All right. Now, the trick here is this is the most generic way of looking at this data and how to linearize it. But in the first part of the video, I showed you what you can do when you compare it to actual physics equations. Okay, so here we use y's, m's, x's, and b's, but in your physics equations, you'll have actual variables. And the trick is all you got to do is replace your variable with the y's and the x's in order to get a linearized data. Okay, so let's do a quick recap. Remember, the whole point of linearizing our data is to go from a non-linear shape to a linear shape. Okay, all right, so that was a video on how to linearize your data. We'll get a lot of practice this year, so make sure you have this in a safe, secure location, and I'll see you next time. Bye-bye.